Hello all, good evening. Welcome to Unacademy. Today we will see indeterminate forms, which is most simplest topic from your syllabus. Okay, एकदम simple है. एक बार आपको limiting concept पता है तो definitely you can solve any example on the indeterminate form. It's a very simple form to evaluate the any given indeterminate form. क्या है सब every type we will see 0 upon 0 indeterminate form, infinity upon infinity indeterminate form, also 0 into infinity indeterminate form. But in this lecture we will see 0 upon 0 and infinity upon infinity indeterminate form. Okay, before going to start this, let me introduce myself. Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University, and I also mentor 10,000 plus students for the engineering. And yeah, here I'm going to tell you a brief review how to install the Unacademy's learning app. Now, first go to your mobile's Play Store app, then search Unacademy's learning app. Then second, install the app. After that, manage your goal here. जैसे कि हम लोग अभी यहाँ पे गेट एंड ईएससी के लिए पढ़ रहे हैं, so you have to manage your goal. बहुत सारे एग्जाम्स है यहाँ पे, आप लोग अपने एग्जाम के लिए तैयारी यहाँ पे कर सकते हो. There are different exams. Just here हम लोग यहाँ पे गेट एंड ईएससी के लिए पढ़ रहे हैं, so you can manage your goal here, गेट एंड ईएससी. And after that, take any subscription plan, either for plus subscription, free courses, special classes. Every plan have different benefits. And then press the get subscription button. And most important thing I'm going to tell you here, you have to take your plans either for the 12 months or 24 months, depending upon for which exam you are going to prepare. If you are going to prepare for the GATE 2022, then I will suggest you can manage your plan for 24 months or take the subscription plan for 24 months, so that it will be more beneficial for you. And to get a 10% discount on your subscription fee, you can use my promo code, that is DSP, to get 10% discount on your subscription fees. Next, you can pay your subscription fees by using any one of this method. Now see, the most important event यहाँ पे होने जा रहा है, evolve for the GATE 2022. So you will enroll your name today itself, because अगर आपने ये यहाँ पे enroll नहीं किया, so मैं बता रही हूँ आपको कि आप जो भी अपनी एग्जाम क्रैक करने जा रहे हो 2022 के लिए, so you will get a top educators from the Unacademy, so that your each and every concept will be clear and you can crack your exam for the GATE 2022. So enroll your name today itself. That batch civil के लिए batch start हो रही है from the 28th December in the morning 11:15. And for the GATE 2022 mechanical की batch हमारी start हो रही है, which is starts from again 28th December from 6 p.m. So be there, enroll your name today itself. Thank you. Now, and to get the any unlock free the plan for the Unacademies, so you can use my promo code, that is DSP, to get the 10% discount on your fees. ये स्पेशल क्लासेस है, लाइव टेस्ट सीरीज होगी, क्विज होगी अनअकैडमी के कॉम्बैट के लिए. सो यू कैन यूज माय प्रोमो कोड, दैट इज DSP, टू गेट द 10% discount on any subscription plan. Okay, now we'll start our actual topic, that is indeterminate form. Okay, now we know that when we will get the indeterminate form, sometimes we have a limit of the form, limit as x tends to a, f of x upon g of x as 0 upon 0 or infinity upon infinity, which cannot be determined. Such limit is called as indeterminate. Although मतलब यहाँ पे हम लोग को ऐसे फॉर्म मिल रहा है 0 upon 0 और infinity upon infinity. This type of form is called as indeterminate form. We cannot determine the limit for that function. So हम लोग क्या करेंगे यहाँ पे? We will use the L'Hospital rule. See, although the function f of x, here f of x upon g of x is undefined at x is equal to a, it may however approach a limit as a x approaches to a. The process of determining such limit, if it exists, is known as the evolution. evolution of an indeterminate forms. Okay, हम लोग ये indeterminate form evaluate कैसे करेंगे? Let's see one by one. See, the first indeterminate form 0 upon 0 form. So ये 0 upon 0 form है क्या? पहले देखेंगे limit of if f of x and g of x are differentiable function and f of x limit as x tends to a and limit as x tends to a g of x is equal to 0, both are 0. Then limit as x tends to a f of x upon g of x is equal to limit as x tends to a f dash of x upon g dash of x, and this process will be continue. मतलब अगर यहाँ पे आपको ये form f of x upon g of x 0 upon 0 आ रहा है form, then this process will be continue till that you are not getting the finite number of limits. Okay, you will get the finite number of limits here. So till that the process will be continue. Now see, limit as x tends to a f of x upon g of x is equal to limit as x tends to a f dash of x upon g dash of x. This is called as L'Hospital rules. Okay. Now here log e is equal to 1. The most important things we will use here. The log e, value of the log e is equal to 1. Value of log 1 is equal to 0. Many times we will come with this. So while solving any example on the indeterminate form, so you have to remember this. Log e is equal to 1, log 1 is equal to 0, log 0 is equal to minus infinity, log infinity is equal to infinity, and e raised to 0 is equal to 1, e raised to infinity is equal to infinity, and e raised to minus infinity is 0. एंड द मोस्ट थिंग जो कि हमने 11th-12th में किए हैं ये फॉर्म्स, लिमिट एज एक्सटेंड्स टू 0 tan x upon x is equal to 1, limit as x tends to 0 1 plus x bracket raised to 1 by x is equal to e, and limit as x tends to 0 a raised to x minus 1 upon x is equal to log a, limit as x tends to 0 e raised to x minus 1 upon x is equal to log a, which is equal to 1. Limit as x tends to 0, 1 plus a by x bracket raised to x is equal to e raised to a. Okay, I hope you are clear here how to find out the standard function. These are the standard limits while it is required to solve any example on this. Now next. Now you will see the first example here. Find the limit as x tends to 0 sin x upon x. Limit as x tends to 0 sin x upon x. So what we will do, let here L is equal to limit as x tends to 0 sin x upon x. Now put here value of x is equal to 0. So you will get sin 0 upon 0. But sin 0 is 0. So you will get here 0 upon 0 form. So what will be our process? By L'Hospital rule. By L'Hospital rule, we'll get L is equal to here limit as x tends to 0, derivative of sin x is cos x upon derivative of x is 1, right? So here x cos x upon x, so you will get here, put the limit as x tends to 0. Now cos 0 upon 1, so cos 0 is 1, so limiting value of this function is 1. So limit as x tends to 0 sin x upon x is equal to 1 by using indeterminate form, right? Evaluate limit as x tends to 0 log of 1 plus kx square upon 1 minus cos x. So here put, let L is equal to limit as x tends to 0 log of 1 plus kx square upon 1 minus cos x, right? So limit as x tends to 0. Here put limit as x tends to 0. So you will get log of 1 upon 1 minus cos 0, that is 1. So log 1 is 0, 1 minus 1 is 0. So it is 0 upon 0 form. Right, you will get here 0 upon 0 form. After that L is equal to here. Now see, log limit as x tends to 0 log of 1 plus kx square upon 1 minus cos x. So here you will get again f dash of x. So f dash of this by using L'Hospital rule, by L'Hospital rule, we get here L is equal to limit as x tends to 0. Here log of 1 plus kx square. So log you can derivative 1 upon 1 plus kx square into derivative of 1 plus kx square, that is 2kx. Okay, upon 1 minus of minus sin x, that is sorry, here only sin x. Derivative of minus cos x is minus sin x, and that minus sign, this minus sign becomes plus. So you will get here 1 upon 1 plus kx square into 2kx upon sin x. So put limit as x tends to 0. So while putting limit as x tends to 0, so is it nothing but limit as x tends to 0, 2kx upon 1 plus kx square into sin x. Right? L is equal to limit as x tends to 0. I am writing once again here. 2kx upon 1 plus kx square into sin x, which is equal to limit as x tends to 0. This is 0 upon here x is equal to 0. So this will becomes again 0. So sin 0, you will get here again 0. Right? Again it is 0 upon 0 form. So here we will use L'Hospital rule again. I am talking about this. No, again L'Hospital rule. Again using L'Hospital rule. Okay. Again using L'Hospital rule, you will get here L is equal to limit as x tends to 0. So 2kx, derivative of 2kx with respect to x is 2k upon here first into derivative of second plus second into derivative of first. So that is 2kx into sin x. Okay. Now apply limit as x tends to 0. Put x is equal to 0. So this will become 0. So 2k upon cos 0 is 1. So here is 1 plus sin 0 0, and this will become 0. So 1 plus 0. So value of the given function is limiting value is 2k. I hope you are getting it. No. Next example, see here. A raised to x minus 1 minus x log a. Okay, evaluate the limit. Limit as x tends to 0. A raised to x minus 1 minus x log a upon x square. Here, limit as x, L is equal to limit as x tends to 0. A raised to x minus 1 minus x log a upon x square. Now put x is equal to 0. You will get here at x is equal to 0. So a raised to 0 minus 1 minus 0 upon 0. So again a raised to 0 is 1. So 1 minus 1 0. So 0 upon 0 form. So using L'Hospital rule. Here we will use L'Hospital rule. तो ये क्या हो जाएगा? Limit as x tends to 0. Here you will get limit as x tends to 0. A raised to x minus 1. A raised to x minus 1 minus log x log a minus x into log a upon x square. Okay, so is it nothing but u upon v rule? So here, now f dash, not u upon, f dash of x upon f of x, I'm sorry, limit as x tends to 0. So a raised to x into log a minus log a upon 2x. Now put x is equal to 0. So you will get here x is equal to 0, a raised to 0, 1. So a raised to 0, 1 log a, here is log a. Log a minus log a 0 into 0, 0. So 0 upon 0 form. Again, use limit as x tends to 0, f dash of x, a raised to x log a raised to x into log a. Now this is constant. So upon 2. Now put limit as x tends to 0. So you will get here a raised to 0, 1 log a into log a. So log a square upon 2. Right? This is your final answer. Log a, sorry, log a bracket square upon 2. Now, evaluate the limit. This is very important. Evaluate the limit x raised to y minus y raised to x upon x raised to x minus y raised to y. Okay, how to evaluate these limits? This is very interesting. Now there is no any constant term here. Here is again variable. So differentiating, put x tends to y. So you will get limit as x tends to y. Limit as x tends to y, put the value here, y raised to y. So you will get here y raised to y minus y raised to y upon y raised to y minus y raised to y. So again 0 upon 0 form. Okay, here again 0 upon 0 form. Now differentiating. So limit as x tends to y using L'Hospital tool. As we got 0 upon 0 form. So using L'Hospital rule. Using L'Hospital rule, we can write here. Now, so differentiating with respect to x. So, as we differentiating with respect to x, keeping y constant, right? So, here you will get x raised to y, it means x raised to n, y into x raised to y minus 1 minus y raised to x. So, y raised to x into log y, right? Upon here y raised x raised to x. Now x raised to x minus y raised to y. Okay, so we require here derivative of x raised to x with respect to x. So what we will do, I am keeping here as it is this term and letting f of x is equal to x raised to x. See here, f of x is equal to x raised to x. We cannot differentiate this x raised to x. There is no any other rule to differentiate this x raised to x with respect to x. So what we will do, we will taking log on both sides. Okay, taking log on both sides. So we get log on both sides, we get log of f of x is equal to log of x raised to x, right? So here what we will do, log of f of x is equal to x into log x, right? So differentiating with respect to x. So you will get log of f of x, differentiating this. So 1 upon f of x into f dash of x. Log u, 1 upon u into derivative of u with respect to x. So first into derivative of second plus second into derivative of first. So you will get here f dash of x. So f dash of x upon f of x is equal to here 1 plus log x, but this 1 plus log x is nothing but, so we can write here f dash of x is equal to f of x into 1 plus log x, right? I'm writing on the next page. F dash of x, now see here, f dash of x f dash of x is equal to f of x into 1 plus log x, right? But f of x is, it means what? X raised to x. X raised to x into 1 plus log x, right? f dash of x is equal to x raised to x into 1 plus log x. Now see here, y x raised to x, differentiating with x raised to x, so you will get here x raised to y. Now using L'Hospital rule, I'm taking this as it is by letting f of x is equal to here x raised to x, f of x is equal to x raised to x. So you will get f dash of x is equal to x raised to x into bracket 1 plus log x. Okay. So now we will take our actual function f of x here. So here f of x is equal to limit as x tends to y. Here x raised to y minus y raised to x upon x raised to x minus y raised to y. Okay. So here L is equal to. So put x raised to x, y raised to y. So again you are getting 0 upon 0 form here. So after that 0 upon 0 form. So using L'Hospital rule, we have L is equal to limit as x tends to y. Here y into x raised to y minus 1 minus y raised to x into log y, because we are differentiating with respect to x, upon now x raised to x. So x raised to x is nothing but x raised to x plus 1 upon log x, and y raised to y is constant, so we are differentiating with respect to x is 0. Right, now again put x tends to y. So as x tends to y, you will get limit as x tends to y. Here y into y raised to y minus 1. Right, we will write here L is equal to y into y raised to y minus 1 minus y raised to y into log y upon y raised to y into 1 plus log y. Right? So y raised to y into log y. So y into y raised to y minus 1, this will become y raised to y 1 and minus 1 get cancelled out, y raised to y minus y raised to y into log y upon, here is y raised to y upon 1 plus log y. Now if I take y raised to y common, so this will becomes 1 minus log y upon y raised to y into 1 plus log y. So y raised to y raised to y get cancelled out. 1 minus log y upon 1 plus log y. This is your final answer for the given function f of by using L'Hospital rule. While putting the values of x tends to y, we are getting the indeterminate form, that is 0 upon 0. And after evaluating by using L'Hospital rule, he will get the answer is 1 minus log y upon 1 plus log y. Okay, I hope it is totally clear to you. Okay, now next is indeterminate form, infinity upon infinity indeterminate form. Okay, let limit as x tends to a, f of x is equal to infinity, limit as x tends to a, g of x is equal to infinity, then limit as x tends to a, f of x upon g of x is in infinity upon infinity form. Right, limit as x tends to a is f of x is equal to infinity, limit as x tends to a, g of x is equal to infinity, then limit as x tends to a, f of x upon g of x is in infinity upon infinity form, which can be determined as follows. Let limit L is equal to limit as x tends to infinity, f of x upon g of x. It is infinity upon infinity form. So this infinity we can evaluate into this form, 1 upon infinity upon 1 upon infinity, 1 upon g of x. It means here the same form we can convert it into 1 upon g of x into 1 upon f of x. It means we are converting your infinity upon infinity form into 0 upon 0 form. So again applying the same way by using L'Hospital rule. Now note that L'Hospital rule is directly can be applied if limit is in the infinity upon infinity form. This is very important. So let's start our next example. evaluate. Here evaluate, limit as theta tends to pi by 2, log of theta minus pi by 2 upon tan theta. Okay, limit as theta tends to pi by 2, log of theta minus pi by 2 upon tan theta. Now we will first put the limit as theta tends to pi by 2. So log of pi by 2 minus pi by 2, that is log 0 upon tan pi by 2, right? Log 0 is infinity, tan 90 is again infinity here. So here is infinity upon infinity form, right? So here is infinity upon infinity here, infinity upon infinity form. So you will get here 1 upon, by using, directly we can use by using L'Hospital rule. By using L'Hospital rule, we have L is equal to limit as theta tends to pi by 2. Now here differentiating with respect to theta. So log of theta. So 1 upon theta minus pi by 2 into derivative of theta, that is 1 upon tan theta, derivative of tan theta is sec square theta. Now if you observe, it is nothing but limit as theta tends to pi by 2, 1 upon sec square theta, it means cos square theta upon theta minus pi by 2. Right, now put theta is equal to pi by 2. So again cos pi by 2 upon theta pi by 2 minus pi by 2. So you are getting 0 upon 0 form. Okay, again we will use L'Hospital rule. Right, so by using L'Hospital rule, we have here log of limit as theta tends to pi by 2. What is the derivative of cos square theta? It is 2 cos theta into minus sin theta, right? U raised to n upon theta minus pi by 2, it's only 1. Okay, now put theta is equal to pi by 2. So limit as theta is equal to pi by 2. Here you will get L is equal to cos pi by 2 is cos 90 is 0. So here ultimately you will get limit is 0. Limiting value of this function is 0 as theta tends to pi by 2. I hope you are getting clearly how to find out the limiting value of the given function when the function is in indeterminate form. Okay. Now let's see the next example. Evaluate limit as x tends to 0, log to the base tan x into tan 2x. Right? Log to the base tan x into tan 2x. So what we will do, we will first of all convert this function into this form. So limit as, so L is equal to limit as x tends to 0. So log of tan x, tan 2x to the base tan x, we can convert this into log of tan 2x upon log tan x. Okay, so if you put x is equal to 0, tan 0, here is 0, tan 0, 0. So you will get tan 0, 0, log 0, infinity. Again here, so this is your infinity upon infinity form. Now using L'Hospital rule, we can write here L is equal to limit as x tends to 0. Here is log of tan 2x. So log tan 2x हो जाएगा यहाँ पे 1 upon tan 2x, right, into sec square 2x into derivative of 2x, that is 2, upon log tan x 1 upon tan x into derivative of tan x is sec square x. Right, now this simplify, which is equal to limit as x tends to 0. Here you will get sec square 2x upon So is it nothing but now sec square 2x upon 2. So tan 2x upon tan 2x, directly put the limiting value as limit x tends to 0. So tan 0 here, tan 0 0. So this will becomes again 0, right? So but limit as, we know that limit as x tends to 0, tan x upon x is equal to 1, right? So what we will do, we will write down this as 1 upon tan 2x. So you will get 2 tan x, this function, 2 tan x into sec square 2x upon tan 2x into sec square x. Okay, tan 2x into sec square x. Now what we will do, whenever there is limit as x tends to 0, so try to convert it into 2 tan x upon x form. So we can write here tan x upon x square, here limit as tan 2x upon 2x. So you will get L is equal to limit as x tends to 0. See, here we are adjusting the term to tan x. We can write that x, we will adjusting here 2 into tan x upon x, right? 2 is already here, into sec square 2x, right, upon here 2 into tan 2x upon 2x into sec square 2x, right? So limit as x tends to 0, tan x upon x is equal to, you will get limit as x tends to 0, tan x upon x is equal to 1. So tan 2x upon 2x is also 1. So 2 into sec square 2x upon sec square 2x, sec square x होना चाहिए, right? Upon sec square x, not 2x. Here is upon sec square x. So you will get here limit as x tends to 0. Now this 2 into, and sec 0 is 1. Here 2 into sec 0 again is 1. So 2 upon 2, that is value of this function is 1. I hope you are getting it. The function is different. How to evaluate this? See, limit as x tends to 0, log of tan 2x to the base tan x. We can evaluate by using this, by using L'Hospital rule. So we are getting here infinity upon infinity form. So try to convert it into 1 upon g of x upon 1 upon f of x. So if it is infinity upon infinity, then also we can apply directly L'Hospital rule. So by using that L'Hospital rule, we can write it here. So 2 into tan x upon x, here is 2 into tan 2x upon 2x. Now if you observe, this will also get cancelled out. To adjusting this 2, we are adjusting here. These 2, we are adjusted here, and here 2 already 2 for this derivative of this. So 2 is already here, and we are adjusting this to x upon 2x, and that 2 is adjusted here, right? Now next, evaluate limit as x tends to a, log of x minus a upon log of a raised to x minus a raised to a, right? So limit as x tends to a here. Now put the value, limit as x tends to a, log of a minus a, that is log 0, upon log of a raised to a minus a raised to a. Log of 0 is 0, so 0 infinity, log 0 is infinity, so it is infinity upon infinity form. Okay, using L'Hospital rule. Using L'Hospital rule. So here you will get limit as x tends to a, here log of 1 upon, so here is 1 upon x minus a upon, there is log of a raised to x minus a raised to a. So here you will get 1 upon a raised to x minus a raised to a into a raised to x log a. Right here a raised to a constant. So derivative of a raised to x is a raised to x log a. So which is nothing but limit as x tends to a. Here 1 upon x minus a into a raised to x into log a. So here is a raised to x minus a raised to a. Now put here again x tends to a, so a raised to a minus a raised to a, again here is 0 upon 0 form, right? Here is 0 upon 0 form if you observe. So again use the L'Hospital rule, right? Again using L'Hospital rule. Again here using L'Hospital rule, we will get limit as x tends to a. Here is a raised to x. So a raised to x, limit of a difference derivative of a raised to x is a raised to x into log a minus a raised to a is constant, so derivative is 0. Now here x minus a into a raised to x log a. Now if you observe here, log a is constant into x minus a. So again you will use u into v rule. So log a is constant, we will keep it as it is. So here first into derivative of second, right? So x minus a into derivative of second is a raised to x log a raised to x का derivative. Now second into derivative of first. So a raised to x into derivative of x minus a is 1. So here you will get limit as x tends to a raised to x log a upon, now multiply with log a, you will get here a raised to x into log a, right? So just put value of x is equal to a. So a raised to a upon log a minus a into a raised to a log a plus a raised to a. So again I think this is a raised to a log a. Now this is a raised to a log a. This will become 0, right? A minus a is 0, so this is 0. So a raised to a into log a raised to a into log a. So a raised to a log a upon a raised to a log a is equal to 1. So value of this indeterminate form is 1. I hope you are getting it. No. The next example. This is different example of the indeterminate form. Okay, expansion of this series here we are taking. Now 1 square plus 2 square plus 3 square plus and so on plus n square upon n cube. Okay, here find out whether, check whether it is infinity upon infinity form. Obviously you will get it is infinity upon infinity form if you put n is equal to infinity. So it is infinity upon infinity form. So here is infinity upon infinity form. Now here 1 square plus 2 square plus 3 square. So first what we will do, we will expand this. Okay, we will expand this 1 square plus 2 square plus 3 square plus and so on n square. We will write this as n into, now we know that the sum of first n natural number, squares of sum of squares of first n natural number is equal to n into n plus 1 into n plus 2 2n plus 1 upon 6, right? It is upon 6 into this n cube, right? So we can take n common, so you will get 1 by 6 into bracket here, take n common, n into, here is 1 plus 1 by n, here is 2 plus 1 by n, right? So n into n upon n cube. So what we will get, n into bracket this n outside, and n into, here is again n into, so this n and this n becomes n cube. So you will get limit as n tending to infinity, here is 1 by 6 constant outside. So n into n, it means n cube into bracket 1 plus 1 by n into 2 plus 1 by sorry, upon n cube, right? So this n cube will get cancelled out. So now put n limit as n tending to infinity. Here limit as n tending to infinity, you will get 1 upon infinity is 0. Again 1 upon infinity is 0. And this 1 into 2, that is you will get again here is 2. Right? So 2 by 1, 6 this. So 2 by 6 it means 1 by 3. I hope you are getting it. Now it's a very simple, but you must know that this series expansion, sum of first n square is n into n plus 1 into 2n plus 1. Okay. Now by using the mathematical induction part from the discrete mathematics, that you must know how to evaluate this. Okay. Now next. Evaluate limit as x tends to 0 cot x minus 1 upon x upon x. Wow, this nice example. Cot x minus 1 upon x limit as x tends to 0. Now put the value of limit as x tends to 0 here. So instead of using cot x directly, what we will do, we will apply here cos x upon sin x. So that will be more simple. So limit as x tends to 0, here is cos x upon sin x minus 1 upon x, which is equal to x cos x minus sin x upon x into sin x. So it will give you x square sin x, right? So limit as x tends to 0, limit as x tends to 0, x cos x minus sin x upon x square sin x. So which is equal to limit as x tends to 0, x cos x minus sin x upon x square sin x. Now put limit as x tends to 0. So you will get here x tends to 0. So 0 upon 0 form, 0 upon 0 form. So apply here using L'Hospital rule. Here we will use using L'Hospital rule. We have here we will use L'Hospital rule. We have limit as x tends to 0, right? First into derivative of second, that is minus sin x, plus second into derivative of first, that is 1, and minus cos x here upon first into derivative of second plus second into derivative of first, first into derivative of second plus second into derivative of first. Now use plus 6 cos x minus cos x get cancelled out. Now use x tends to 0. So here x tends to 0. Again you will get here is 0, here is 0. So again 0 upon 0 form. Okay. Here you are getting 0 upon 0 form. Now here, now if you observe, so always you will get here minus x sin x upon 2x sin x. So always you will get this 0 upon 0 form. So what we will do, we will write here this sin x, adjusting the sin x by x term. We will adjust the term sin x by x. Why? Because we know that limit as x tends to 0, sin x by x is equal to 0. Limit as x tends to 0, sin x by x is equal to 1. Okay, so how we can adjust it? See here, cos x, x into cos x minus sin x upon x square sin x. So we will do here x cos x minus sin x upon x, and here x into bracket sin x, here x square into bracket sin x upon x. Okay, so we will get here cos x upon x, cos x minus sin x upon x upon limit as x tends to 0, because always you will get here x term. So always you will get 0 upon 0 form. So you must have to adjust the term. Okay, so here x into bracket sin x upon x, square into bracket sin x upon x. Now this x and this x we adjusted already. By dividing numerator and denominator by x, you will get this. Now put here limit as x tends to 0, limit as x tends to 0, here cos 0 is 1, right? Here cos 0 is equal to 1, or you can directly apply here cos x minus limit as x tends to 0 sin x upon x is equal to 1, here upon x square. Now use again 0 upon 0 form, you will get limit as x tends to 0 cos 0 is 1, cos 0 1, 1 minus 1 upon 0, so 0 upon 0 form again use the L'Hospital rule, again use L'Hospital rule. Okay, so limit as x tends to 0, derivative of cos x minus sin x here upon 2x. Now again you can adjust the term, here 1 by 2 minus 1 by 2 into limit as x tends to 0 sin x upon x. So you will get limit as x tends to 0 sin x upon x is equal to 1. So here is minus 1 by 2 is the final answer. Okay, minus 1 by 2 is the final answer for the given function f of x. Now here f of x is equal to, here you will get f of x is equal to no, limit as x tends to 0, just a minute, hold it. Okay, the limit as x tends to 0 sin inverse of x minus x upon x cube. Now here we will use the expansion of the function. So expansion of the function by using Taylor series or Maclaurin series, you will get here sin inverse of x, here sin inverse of x is equal to x minus x plus x cube by 6 plus 3 by 40 x raised to 5 plus and so on. This is series expansion of the function sin inverse of x. Now here L is equal to limit as x tends to 0. Here you will get x plus x cube by 6 plus 3 by 40 x raised to 5 plus and so on minus x upon x cube. Okay. So limit as x tends to 0. Here is 1 upon 6 into x cube plus 3 by 40 x raised to 5 and so on. Right? So 1 upon x square. So here you will get with x cube upon x cube. So divided by terms of x with power greater than 5. So you will get this. So 1 upon limit as x tends to 0. Here you will get 1 by x upon 1 by x cube. So you will get this 1 by x plus 3 by 60, 3 by 40 into x raised to 2 plus terms containing x. So every term will contain the x. So putting limit as x tends to 0. So it will gives you 1 by 6. I hope it is clear to you how to get this function f of x is equal to its sin inverse of x minus x upon x cube. If you are limiting in this form, so by using the expansion of the given series, we can find out the indeterminate form. Here we will see one more example. The limit as x tends to 0. Here we can see limit as x tends to 0. Here example number we will take 11. Limit as x tends to 0. 1 plus x bracket raised to 1 by x minus e plus ex by 2 upon x square. Okay, now we will use limit as x tends to 0. So L is equal to limit as x tends to 0 . So here 1 plus x bracket raised to 1 by x is equal to, now series expansion again you are getting here is 0 upon 0 form. You can check it when x tends to 0. So what is x tends to 0? Limit as x tends to 0, 1 plus x bracket raised to 1 by x is equal to e. Since limit as x tends to 0, 1 plus x bracket raised to 1 by x is equal to e. So e minus e upon, here is x tends to 0, so you will get 0. So here 0 upon 0 form. So series expansion of 1 plus x bracket raised to 1 by x is e minus e by 2 into x plus 5 by 8 into x square minus 3e by 16 into x cube and so on. So here L is equal to limit as x tends to 0, e minus e by 2x plus 5 by 8 ex square minus 3e by 16 x cube and so on minus e plus ex by 2 upon x square, right? Now limit as L is equal to limit as x tends to 0, so after adjusting all this term you will get 5e by 8 into x square minus 3e by 16 into x cube and so on upon x square. So L is equal to limit as x tends to 0, 5e by 8 minus 3e by 16, now dividing by x square, into x. So you will get terms containing all these terms with x. So ultimately limit as x tends to 0, you will get 5e by 8. Okay, I hope you are clear this limiting function and limiting values. Now next we will see limit as x tends to 0. Example number 12. Limit as x tends to 0. Sin x into sin inverse of x minus x square upon x raised to 6. Okay. Now sin x, so using expansion of sin x and sin in, don't cancel out this sin x into sin inverse x. Okay, here we will use the limiting value limit as x tends to 0. So what will happen, many times अरे sin x से sin inverse x है तो ये cancel out हो जाएगा, ऐसे नहीं है. Okay, so L is equal to limit as x tends to 0. So sin expansion of sin x is x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus and so on. Okay, into bracket, here is x plus x cube by 6 plus 3 by 40 x raised to 5 plus and so on minus x square upon x raised to 6 upon here x raised to 6. Okay, so limit as L is equal to limit as x tends to 0, here x minus x square. Now x cube upon 3 factorial is 6, so minus x cube plus x cube, this will get cancelled out. Now you will say here minus x square and neglecting this term, so x square, x into bracket x square, so this will gives you x square, x into x cube by 6 and x raised to 4 by 6 and plus x, so plus x raised to 4 by 6 plus 3 by 40 into x raised to 6 minus x raised to 4 by 6, right? Here minus x raised to 4 by 6 minus x raised to 6 by 36 minus plus x raised to 6 by 120 and so on. minus x square upon x raised to 6. Right, now all the terms now containing x. So if you observe, this plus x square and minus x square will get cancelled out. So you will get a 3 by 40 upon x raised to 6 upon 3 by 40 upon x raised to 6. So this will x cancel out. So you will get 3 by 40. Limit as x tends to 0. 3 by 40 minus 1 by 60 plus 1 by 20 into x raised to 6 plus terms with the power of x greater than 6. Terms with power of x greater than 6 upon x raised to 6. Here upon x raised to 6. Okay. Now, so limit as x tends to 0, 1 by 18 x raised to 6 plus higher power of x upon x raised to 6. So limit as x tends to 0, 1 upon 18 plus terms containing x. Right? So as it contains the terms x, obviously limit as x tends to 0 becomes its 0. So you will get the value 1 upon 18. This is the final answer. Okay. Now next we will see. Let's see the next example. Now see. Very interesting. Find the value of AB. Example number 13. Here we will see find the value of AB if limit as x tends to 0, x into 1 plus a cos x minus b into sin x upon x cube is equal to 1. Okay, upon x cube is equal to 1. Now limit as x tends to 0, so we will see, first of all, find out the form. Limit as x tends to 0, so this 0, this will become 0, this will become 0, so 0 upon 0. Now the limiting value of this function is equal to 1, right? So here is 0 upon 0 form. So let L is equal to limit as x tends to 0, x into 1 plus a cos x minus b sin x upon x cube. Right? So put here x is equal to 0, you will get 0 upon 0 form. Right? We'll using L'Hospital rule, we have here L is equal to limit as x tends to 0. Here is first into derivative of second. So first into derivative of second, that is minus a sin x, plus second into derivative of first, that is 1 plus a cos x minus b cos x, right, upon here 3x square. Right, now here if you observe, put the value of x tends to 0. As x tends to 0, you will get this will become 0. A cos 0 is 1. So 1 plus a cos 0 is 1. 1 plus a minus b, right, upon 0. We will get here L is equal to 1 plus a minus b upon 0. Right, but it is given that it is infinity, but the value of the limit is 1. So this is possible only when, right, so this is possible only when L is equal to this, but here L is equal to 1 given, no? Here limiting value of this function is L is equal to 1 given. So if we put L is equal to 1 here, then what will happen? If L is equal to 1, then obviously you will get this is possible only when this is possible only when this will become 0, right? 1 plus a minus b is equal to 0. Why? Because otherwise this will won't be a 0 upon 0 form. So what it happened by using this a plus b is equal to so a minus b, so which implies a minus b is equal to minus 1. So by using this value of a minus b is equal to 1 in this equation, right, in this equation 1, so this equation 1 becomes 0 upon 0 form, right? Equation 1 becomes 0 upon 0 form. Hmm? So as it becomes 0 upon 0 form, we will use again the L'Hospital rule, right? So using L'Hospital rule again, by L'Hospital rule, hmm? So we will have here limit as x tends to 0, L is equal to limit as x tends to 0. Now use the L'Hospital rule. Here first into derivative of second, again you will get minus a into bracket x into sin x, right? So minus a is constant, x into sin x, first into derivative of second plus second into derivative of first, right? Now here is first a cos x, derivative of 1 is 0, and a cos x minus a sin x, you will get here minus a sin x, and again derivative of this b cos x minus b cos x is minus sin x, so minus sin and plus, so plus b sin x, right, upon 3x upon 6x. Here you are getting 3x square, derivative of 3x square is 6x. Now again use limit as x tends to 0. So as limit as x tends to 0, you will get this terms become 0, this is total be 0, this will become 0, this will become 0. So again it is 0 upon 0 form, right? So again apply L'Hospital rule. By L'Hospital rule, we'll get L is equal to limit as x tends to 0. So here is minus a into bracket first into derivative of second plus second into derivative of first plus cos x minus a into cos x, right, minus a into cos x. So you will get here plus b into cos x upon 6, right? But limit as x tends to 0, put the value of limit as x tends to 0, so this will become 0, this will becomes 1, this will becomes 1, so 1 plus 1 2 minus 2a, this will becomes again 1, so minus 3a, okay, minus 3a plus b upon 6, minus 3a plus b upon 6, but it is given that the value limiting value of this is 1, so you will get here your limiting value L is equal to 1. 1 is equal to minus 3a plus b upon 6. So here minus 3a plus b is equal to 6. Right? Minus 3a plus b is equal to 6. So you will get minus 3a plus b is equal to 6. Then solving equation 1 and 2. So you will get equation 1. A minus b is equal to minus 1. So solving these two, now if I add these two, So you will get value of this minus 2a is equal to 5. So a is equal to minus 5 by 2. Now put a is equal to minus 5 by 2. Minus 5 by 2 minus b is equal to minus 1. So minus b is equal to 1 plus 5 by 2 minus 1 plus 5 by 2. So here minus b is equal to minus 2 plus 5 plus 3 by 2. So b is equal to minus 3 by 2. So value of a and b are minus 5 by 2 and minus 3 by 2. I hope it is clear to you how to find out the value of the given constant a and b when the integral limits are given. I'm sorry, not integral limits, when the uh, value of the value of the function is in the form 0 upon 0 or infinity upon infinity, then how to evaluate the given function f of x, or how to find out the value of the constant. Okay, I hope it is totally understood by you. So if you are liking my videos, please do like, share and subscribe. Thank you so much. I will be here with the next form tomorrow in the same time, in the with the new point, that is indeterminate form of 0 into infinity form, and 1 raised to 0, 1 raised to 0, 1 raised to infinity form, that we will solve in the next lecture. Okay, thank you so much.